Next is question number 76, which says that the vector I cap plus j cap plus 2 into k cap is turned through a right angle about origin. If it passes through the positive y-axis on the way, then the vector in its new position is. The tentative diagram is something like this, where this point is 1, 1, 2, this is origin, 0, 0, 0, and let us say this is the positive y-axis and this is the new point, let us say x, y, z. This vector is turned through 90 degree and we get this new vector, right? Now here we can see that the magnitude of the new vector will be equivalent to the vector which have been turned. Now here we can see that the magnitude of the vector will remain same. So we can say that x square plus y square plus z square will be equal to 1 square plus 1 square plus 2 square, that is equal to 6, right? So this is the one equation. And secondly, we can see that, let us say this is O, A and this is B. We can see that the vector OA is perpendicular to vector OB. Hence, we can put the dot product to be equal to 0. That is, x into 1 plus y into 1 plus 2 into z will be equal to 0, right? And thirdly, we can see that these three vectors are making area 0. That is, we can put modulus of x, y, z. This is, let us say 0, 1, 0, 0, 1, 0, 1, 1, 2 to be equal to 0. So from here we can find that x into 2 plus y into 0 plus z into minus 1, that is minus z is equal to 0. So we have three equations in x, y, z and we can solve it, right? We will get x equal to minus 1 by root 5, y equal to root 5 and z equal to minus 2 by root 5 as one value, and we will get another value as x equal to 1 by root 5 and y equal to minus root 5 and z equal to 2 by root 5. Now in the question it is given that this vector is when turned through a right angle about origin, then it passes through the positive y-axis. So we can say that only this value will satisfy it, because when it gets turned, the x coordinate of the new vector will be negative, y coordinate will be positive and z coordinate will be negative, right? So the correct answer will be option number 4. Next is question number 77, which says that let alpha comma beta be the roots of the equation x square plus 2 minus a into x plus 1 minus a equal to 0, where a belongs to R, then the minimum value of alpha square plus beta square is equal to. Now here it is given that alpha comma beta are the roots of this given equation. So we can say that sum of roots alpha plus beta will be equal to a minus 2 and product of roots alpha comma beta will be equal to 1 minus a. Hence the value of alpha square plus beta square can be equal to alpha plus beta whole square minus 2 into alpha into beta, right? So this is equal to a minus 2 whole square minus 2 into 1 minus a, which is equal to a square plus 4 minus 4a minus 2 plus 2a, which is equal to a square minus 2a plus 2, right? Which can be written equal to a minus 1 whole square plus 1. Now we have to find the minimum value of alpha square plus beta square. It will be equal to 1 when a is equal to 1, right? So the minimum value will be equal to 1. That is option number 4 is the correct answer. Next is question number 78, which says that a non-zero vector a is collinear to the line of intersection of the plane determined by the vectors I cap, I plus j cap, and the plane determined by the vectors I cap minus j cap, comma, I cap plus k cap. Then the angle between a vector and b vector, that is I cap minus 2 times j cap plus 2 times k cap, may be equal to. So let us say this is one plane which is determined by the vectors I cap and I cap plus j cap. And let us say this is the another plane which is determined by the vectors I cap minus j cap and I cap plus k cap, right? Now, a non-zero vector A is collinear to the line of intersection of the plane, so we can say that A vector is somewhere here, right? So we can say that the vector A, I cap and I cap plus j cap are coplanar. So for three coplanar vectors, we can say that, let us say A vector is equal to x I cap plus y j cap plus z k cap. So for three coplanar vectors, A vector, that is x, y, z, I cap, that is 1, 0, 0, I cap plus j cap, that is 1, 1, 0, will be equal to 0. So from here we get that x into 0 plus y into 0 plus z into 1 is equal to 0. Hence from here we get that z is equal to 0. Also vector A, I cap minus j cap and I cap plus k cap are also coplanar. So again we can say that determinant of x, y, z 1 minus 1, 0, 1, 0, 1 is equal to 0. So from here we get that x into minus 1 plus y into minus 1 plus z into 1 is equal to 0. So we can say that x plus y is equal to 0 because z is already 0, right? So we can say that vector A can be written equal to, let us say, lambda I cap minus lambda j cap. Now we have to find the angle between vector A and vector B. So we can say that cos theta will be equal to A dot B upon magnitude of A into magnitude of B. So A vector dot B vector will be equal to lambda minus lambda into minus 2, that is plus 2 lambda upon under root of 1 plus 4 plus 4, that is 9, that is 3 into under root of lambda square plus lambda square, that is 2 lambda square. So this will be equal to 3 upon 3 into under root 2, which is equal to 1 by root 2, that is cos theta is equal to 1 by root 2, that is theta is equal to pi by 4. So the correct answer will be option number 3. Next is question number 79, which says that let A is equal to matrix AP1, BQ1, CR1 and B is equal to A square if A minus B whole square plus P minus Q whole square is equal to 25. Also B minus C whole square plus Q minus R whole square is equal to 144 and C minus A whole square plus R minus P whole square is equal to 169. Then determinant of P is equal to. In this question, let us make a triangle whose three coordinates are A, B, C. Let us say A is A comma P and B is B comma Q and C is C comma R, right? So we are given that under root of A minus B whole square plus P minus Q whole square is equal to 5. This have been given to us. So we can say that the distance AB is equal to 5. Also it is given that under root of B minus C whole square plus Q minus R whole square is equal to 12. So this distance is 12. And similarly, we can see that the distance AC is given to be equal to 13, right? So here we can see that this triangle is right angled triangle where this is B, this is A and this is C. Now here we can see that area of the triangle ABC is equal to half into 12 into 5, which is equal to 30, right? Also its area 30 can be written as half into determinant of AP1, BQ1, CR1, right? This is what we get from here. Now we have to find the determinant of B, which it is equal to determinant of A square, right? That is equal to determinant of A, that is AP1 BQ1 CR1, determinant of A whole square. Now this is equal to, we know the value of this determinant is equal to 30 into 2, that is 60. So 60 whole square will be equal to 3600. So the correct answer will be option number 2. Next is question number 80, which says that if a non-trivial solution of the system of equations x plus lambda y plus 2z equal to 0, comma 2x plus lambda z equal to 0 and 2 lambda x minus 2y plus 3z equal to 0 is x equal to a, y equal to b, z equal to c, then the value of a plus 4b upon b minus c is. As for the given system of equations, we have non-trivial solution, which means that apart from 0, 0, 0, we have some other solution also, right? So the determinant of 1 lambda 2, 2, 0 lambda, 2 lambda minus 2, 3 is equal to 0. That is 1 into 2 lambda plus lambda into 2 lambda square minus 6 plus 2 times minus 4 is equal to 0. So we can say that 2 times lambda cube plus 2 lambda minus 6 lambda, that is minus 4 lambda minus 8 is equal to 0. That is lambda cube minus 2 lambda minus 4 is equal to 0. That is lambda minus 2, because it have one of the factors as 2. So it can be written as lambda minus 2 into lambda square plus 2 lambda plus 2 is equal to 0. Now it have non-real roots, so the only value of lambda will be equal to 2 here, right? So the given system of equations are x plus 2y plus 2z equal to 0, 2x plus 2z equal to 0 and 4x minus 2y plus 3z equal to 0. So we have x equal to minus z, right? So let us take x equal to t, right? If I have x equal to t, then the point that will satisfy the given system of equations will be t, comma, y will be equal to find the value of y, let us put the value of x and z in equation 1. So we'll get t plus 2y plus 2 times z. Z will be equal to minus t equal to 0. So 2y will be equal to 2t minus t, that is t. Hence y will be equal to t by 2 and z will be equal to minus t, right? Now it is given that the non-trivial solution is x equal to a, that is a is equal to t and b is equal to t by 2 and c is equal to minus t. Hence we can find the value of a plus 4b, that is t plus 4 into b, that is t by 2 upon b minus c, that is t by 2 plus t. So this will be equal to 1 plus 2, that is 3 upon 1 plus 1 by 2, that is 3 by 2. So this is equal to 2. Hence the correct answer will be option number 2.